Okay, here's the closure problems for chapter 4. Um, One thing that you really need to study and have down in your memory is the unit circle, knowing the degrees in radians, the locations of each of them, the degree and how to count them, the degrees in or the angle measures in degrees, and the coordinates for each of them. So being able to draw yourself a picture of this during a test is a huge benefit. So I pulled up a picture of this so I can look at this. Now, on a test, you would need to construct this on your own. So let's take a look at each of these. Let's look at this first one right here. We're trying to find the sine of 5 pi over 3. So first thing, another thing to keep in memory is that the y values on here are sine, and the x represents the cosine. Y values being this direction, and the cosine this direction. So sine of 5 pi over 3, so we would count around or locate 5 pi over 3 right here, and we're looking for sine, so that is the y value. It's this distance here. It's a negative square root of 3 over 2. It's negative square root of 3 over 2. Okay, we're looking for cosine of negative pi over 4. So we need to remember that if it's negative, we're going the opposite direction. So I'm going this direction, the distance pi over 4, which lands me right here. Okay, cosine of that is the x value. So that's positive square root of 2 over 2. And we continue in that same kind of process here. We need to locate 5 pi over 6. It's in the positive direction, so we can use this normal one. 5 pi over 6 is right here. And we want the cosecant of that. Well, the cosecant is defined as the reciprocal of the sine function. So sine is the y value, 1/2, and the reciprocal of that is 2. Moving on to the next one, tangent of pi over 2. So we need to locate pi over 2. Pi over 2 is right here. Tangent is the opposite over the adjacent, or in other words, y over x. The y value is 1. The x value is 0. So 1 over 0, which is undefined. Cotangent of 5 pi over 3, so we need to locate 5 pi over 3. Cotangent is the inverse of tangent. Tangent would be the y over the x. So cotangent is going to be x over y. So it's going to be 1/2 over negative square root of 3 over 2. So we need to simplify that. This is going to be the same as 1/2 times negative 2 over square root of 3. The 2's cancel out, and we have negative 1 over square root of 3. If we want to rationalize the denominator, we multiply by square root of 3 over the square root of 3. So we end up with negative square root of 3 over 3. So long way to that one, but there's the final result. And the last one, secant of 7 pi over 6. Okay, well this one goes more than one time around, so we're not going to find that on here. 6 pi over 6. Actually, I lied. It's only right here. Okay. Yep, it's right there. 7 pi over 6 right here. Secant is the reciprocal of cosine. Cosine is x. So here's my x value, and I need the reciprocal of that. So the reciprocal of that is going to be -2 over the square root of 3. And again, we should rationalize the denominator by multiplying by square root of 3 over the square root of 3. And we get -2 root 3 over 3. And there's that one. Okay, this next problem that we're going to practice is finding the equation of a graph. And we're going to see if we can write an equation for this in terms of sine and in terms of cosine. So let's start by working on part A in terms of sine. So start with a y equals. I know that my center line of this picture is right here at 2. So I can tell that there's going to be a big +2 at the end because my center line was moved up. Let's start by using sine. So I'm going to put sine right here. And we're using alpha, so instead of x, we could use x. It really doesn't matter. So I know my amplitude is, looks like it's 2 above, 2 below the center line. So I'm going to have a 2 right there. In terms of sine, a normal sine begins right here. It begins at the center line. So it looks like my beginning point of sine has been shifted over by pi over 2. So I'm going to shift to the right, we do a minus. So it's going to be alpha minus pi over 2. And when I take a look at the period is 1 complete in a distance of 2 pi, so I do not need to change that. Also, is it positive? Yep, it starts from here and goes up, so I think this is good. So there is a possible equation in terms of sine. Now if we want to do this in terms of cosine, two things stay very similar. We're going to keep the amplitude of 2. We're going to change it to cosine. Our center line was still moved up 2, so we'll have a +2 right there. We'll do alpha in here. So what for cosine did it need to be shifted? Not really. Cosine you can start right there on either, looks like to me an upside down cosine, because normal cosine would start up and go down to the center line and go down. This one starts down, moves up, up, down. Okay, so I don't think I need to shift it right or left. So I'm not going to add anything on here, but it looks like it got flipped over. So I'm going to put a negative here in the amplitude, and that makes a possible equation right there. Okay, this one, being able to simplify trig functions. We want to express this one as a single trig function. So to study for this test, you really need to get all of these memorized. The ratio for tangent, the inverse cotangent, the ratios for cosecant and secant. Always try to remember that if you start with cosecant, it's going to be the inverse with the one that starts with S instead, and then secant gives you the inverse of the one that starts with C. They seem backwards from each other, and that's how I remember it. You also need to keep memorized to the cosine squared plus the sine squared equals 1. So first strategy that's good is to take anything that's not sine or cosine and switch it out. So I see this secant, and I'm going to change that to 1 over cosine. So I've got 1 over cosine of x minus cosine of x. I might as well put a 1 under that to make it a fraction to go along with it, and then I've got sine of x still underneath. Now up top I've got two pieces, so let's make a common denominator and put them together. So to make a common denominator of cosine of x, I'm going to multiply this piece by cosine of x over cosine of x, which is going to make this part cosine squared and that cosine of x. So the next step here, I'm going to have 1, and when I put that together, minus cosine squared of x over my denominator, which is cosine of x, all over sine of x. And when I simplify this, I'm going to need to do an invert and multiply because it's a fraction divided by a fraction. So I also notice that this piece here is the same as sine, because if I subtract cosine of x from both sides, I get 1 minus cosine, so that is the sine squared. So I'm going to replace this piece with sine squared of x, and then it's still over cosine of x, and it's all divided by sine over 1, so I'm going to invert that and change it to multiplication, so I have 1 over sine of x. Now I can simplify across, so if I divide this by sine and this by sine, it's no longer a sine squared, it's just sine, so I end up with sine of x over cosine of x. And that is all the same as tangent, as we can see. So our final result is tangent, is tangent of x. Okay, 151, we're taking a look at a review of how to sketch a trig function and describe the key parts of the graph. So in A, we know it's a sine curve, and we know that sine begins on the center line, and then we go up, and then we go back to center line, and then we go down, and then we go back to center line, and that's the typical pattern. And we've got an amplitude of 2, and my center line is moved up to 1, so I'm going to go ahead and dash in a center line right here. And I also see that I'm shifted pi over 4 to the right. The minus indicates to the right because it's not minus a negative, that would make it plus. So pi over 4, that's halfway between 0 and pi over 2, so that'd be right here. So this is my new starting point. So I'm going to start on the center line at pi over 4. Then my next benchmark is going to be shifted to the center of these two. It would normally be pi over 2, but it's now in between these two, and I know I go up with an amplitude of 2. So there's my next of 5 points, and then I go back down to center line between these two, and then down 2 in between these 2 points, and then back to center line and sketch the curve. So there we have it. Now let's take a look at the next one. Okay, part B. This time we have a flipped over cosine. And so a cosine typically starts up and then moves down, but it's upside down. So this one's going to start down, and then it's going to go to center line, and then it's going to go up to the top, and then it's going to go back to the center line, and then it'll end down. So this will be my little map for that. And that takes care of the negative and the cosine. Also, I've got an amplitude of 3 and a center line of -2. So the center line's here. With the amplitude of 3, my maximum is gonna be here. That's the top, and then the bottom is 1, 2, 3 below that, so at -5. So that kind of gives me the structure. Okay. We need to think about our very first point, -3 below. So here's the very first point. I'm not shifted right or left, but I do have a b value right here. So the period of the new one, and it's going to complete a full cycle by the time we get to pi. There will be 2 complete ones before we get to 2 pi. So this will be the ending point right here. And my maximum point will be here, and then the other 2 will be halfway in between. So that gives me a curve that goes like this. And then to repeat that again, be here And here, that's what that one looks like. Okay, and then the last one, C. This one's in a strange format. Normally, we do not have a number right here at the beginning. I've got a 3 minus sine of x. Okay, so a normal format for this would be y equals negative sine of x plus 3. 'Cause that's a positive 3. Let's move it to the end so it looks like what we're used to seeing. So that means the center line was moved up 3. So here's our center line. It's a sine. So we know we're going to go center up, center down, center. And it's a negative sign. So, and the amplitude is -1. There's an understood 1 right here. So I'm going to start at -1. Oops, wait. Now I'm going to start on the center line. And since it's flipped upside down, instead of going up, we're going to go down. And so down, and then back to center line, and then up, and then back to center line. So there's that curve.